Hi darlings, we're going to talk about the homologous series of hydrocarbons, pretty much everything on table Q and how to interpret in table Q. So these include things called alkanes, alkenes, and alkynes. So what you'll need today is a pen and paper for notes, table Q and table P. So the homologous series, they just show different families of hydrocarbons, specifically the number of bonds between carbons. And again, this is on table Q, and it's called the homologous series of hydrocarbons. So whenever you see a multiple choice question on the Regents that asks about homologous series, it's just dealing with table Q. So we have three members of the families. We have alkanes, alkenes, and alkynes. Each of them have their own general formula. And over on the right show examples. So we have, for alkanes, we have the name ethane, and they show the structural formula for it. Alkenes, an example of that is an ethene, and the structural formula for that, which actually is a little different. So think about why they're different. And alkynes, the example for that is an ethene, and their structural formula. We'll also use table P. These are prefixes. So these prefixes will be pretty much go right in front of whatever type of alkane, alkene, alkyne that you have, whatever homologous series that you have. So when we just looked at ethene and ethyne and ethane, it showed that they had two carbons. So the prefix eth means two. You've seen pent before, that means 5. Hex is 6, hept is 7, oct 8, and so on. So in case you forget some of these, you can always refer back to table P. So we'll look at alkanes. We have to look at all 4 of these formulas to see what we notice. Go back, sorry. So we have methane, ethane, propane, and butane. So what do we notice here? We see that they're only carbons and hydrogens. There's no other elements besides carbon and hydrogens. That's why they're called hydrocarbons. And they all have single bonds between the carbons. Also, all the names, end in A-N-E. So we have methane, ethane, propane, and butane. They have a general formula which we take straight from table Q. It's C, little n, subscript n, H2n plus 2. So that n stands for the number of carbons that we have. That's something that's easily missed by a lot of chemistry students, so make sure you keep an eye on that. Again, the n stands for the number of carbons you have. We also call alkanes saturated hydrocarbons, meaning that they're filled with hydrogen. So every spot that carbon can have has hydrogens. So they all have single bonds and attached to hydrogens where possible. Table Q shows us, again, the homologous series. So for the alkanes, we have the general formula Cn H2n plus 2. If you forget that the n represents the number of carbons, they tell you right down here. So let's take a look at these. We have methane, ethane, propane, and butane. So we're actually going to test, or I'm going to show you how to plug in the number of carbons into the general formula. So we'll use methane as the first example, and I'll divide it there. We know that we have Cn H2n plus 2, so the n stands for the number of carbons. So in meth, if we look back at table P, that should be 1 carbon. So we have 1 for the carbon. Next, we'll plug in for the number of H's. So we have 2 times 1, because that 1 is the n, that's from the number of carbons, plus 2. So we should have CH, and then so 2 times 1 is 2, plus 2 is 4. We'll count them up. We have 1 carbon, and then 1, 2, 3, 4 hydrogens, so that matches up. Let's plug into ethane just to make sure that they're good to go. Let me divide this up so it's easier for you guys to see. The prefix eth means 2. So we have C2, and then we'll plug in to the formula. So we have 2 for the general formula. We'll plug in 2 for n plus 2. Okay? So this will be equal to C2. And then here we have H. It's 2 times 2 is 4. Plus 2 is 6. So double check to make sure that works. We have 2 carbons, and then 1, 2, 3, 4, 5, 6 hydrogens. For propane, the prefix prop means 3. So it's C3. Let's plug this in again. H 2 times 3, because our N, or the number of carbons, is 3, plus 2. So we'll have C3, and then we'll look at the H's. So we have 2 times 3 is 6, plus 2 more, so we should have 8. Okay, so we have our 3 carbons, 1, 2, 3, and then we'll count up the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, and 8. And we'll do butane. The prefix but means 4. So we have C4, and then H, 2 times 4, plus 2. So we'll see C4, and then H. So 2 times 4 is 8, plus 2 is 10. Okay, so we'll count up the number of carbons. 1, 2, 3, 4. And the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so that's how you use the general formula. We'll put this into action for some examples. We have pentane and heptane. So I put table P right here just to remind you to make sure that you use it. Look up the prefix. So these questions want the formula. Oopsies, sorry. They want the formula, and they want you to draw the structures this time. All right. So the formula for pent. We know pent has 5 carbons. So we'll show C5, and then we'll plug into our general formula. H is 2 times 5 plus 2. So we'll have C5, okay, and then for H, it'll be 2 times 5 is 10 plus 2 more, so we'll have 12 hydrogens. And now we'll draw the structure. To draw these, we just draw the carbons out first. This might look a little messy, and I apologize. It's as thin as the stylus can get, unfortunately. But I do want you guys to be able to see this. All right, so we'll show the 5 carbons first. So 1, 2, 3, 4, 5. These are all single bonded to one another. And we know each carbon can have 4 bonds. So we already have 1 bond here. 2, 3, 4. This carbon right here has 1, 2. We'll put 2 more around, and we'll keep doing the same thing. Now, if we leave these blank, just those dashes without the hydrogens, we're assuming that the rest of them might be carbons. So we can't do that. We have to make sure we fill in the carbons, and we have to double check to make sure we have the right number. So I'll start anywhere each place. I'll start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Good. So our formula is good to go. We have C5H12 that we just drew. Now we'll go into heptane. So heptane, and we'll look over here at our table P. Hept means 7, so we need to have 7 carbons. So we'll write out the general formula first, C7. And then we'll plug in. So H, 2 times 7, plus 2. So it'll give us C7. 2 times 7 is 14, plus 2 more. So we should have 16 there. And now we will go ahead and draw these. So again, sorry for the messy drawings, but we'll draw the carbons first. 1, 2, 3, 4, 5, 6, 7. Let me double check. 1, 2, 3, 4, 5, 6, 7. We know carbon can have 4 bonds, and these are all going to be single bonds since they're all alkanes. So 1, 2, 3, and we'll keep plugging these all in. And we have to draw the hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Right? So those are the alkanes. They're all single bonded carbons. We'll take a look at alkenes now. So enes, or the alkenes, will end, we'll go through, again, still they all have carbon and hydrogens. This time we actually notice that there are double bonds between some carbons. So double bond between this carbon, double bond here, and a double bond there. And all these words end in ene. The general formula is CnH2n, meaning that for however many carbons you have twice as many hydrogens. We call this an unsaturated hydrocarbons just because we have carbons that are attached to a double bond to other carbons as opposed to all hydrogens. So these are going to be unsaturated hydrocarbons. All right. And again, on table Q, these are the alkenes. This is its general formula. The example is ethene, and eth means two. Ene would be the ending for alkenes for their series. Okay. So we'll take a look at ethene, propene, and butene. Let's double check to make sure we can plug these right into our formulas. And I'm having you guys do this because this is something that many students have trouble with. So they are unable to plug into the formula. So I want to make sure that you guys are good to go. So for ethene, we have two carbons because the prefix eth means two. So it's C2, and then H is 2 times 2. So we have H4. So we have two carbons and then 4 hydrogens. All right, we'll go ahead and look at propene. The prefix prop means 3, and if you forget that, there's table P to help you. So I have C3, H2 times 3. Okay, so I have C3, H6. So 1, 2, 3 carbons, 1, 2, 3, 4, 5, 6 hydrogens. And then butene, the prefix but means 4, so C4, and then H2 times 4, so we have C4H8. So we'll double check them, 1, 2, 3, 4 carbons, and then 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. All right. We'll do some examples. Pentene and heptene this time. Last time we did pentane and heptane. This time it's ene, so we need to have a double bond in there. And we will go into more in depth on how to name these structures, but for now we're just going to put the double bond right between the first and second carbon. You'll see later on why we do that, but we just want to show you guys now that at least how to draw these briefly. Okay, so pent we know has 5 carbons, so we will go ahead and do the formula first. C5, and then H is 2 times N, so 2 times 5, so C5H10. And like I said before, we're just going to do the double bond between the first and second carbon. Later on I'll show you where the double bonds can be and how we name them. So we have 1, 2, 3, 4, 5. Now we have to double check to make sure we know how many bonds carbon can have. So carbon, this carbon right here, already has 1 and 2 bonds. So it can only have 4 bonds total, so we're only going to put 2 hydrogens there. This carbon number 2, and we'll number them, 1, 2, 3, 4, 5. So carbon number 2 already has 1, 2, 3 bonds, so we can put 1 more for hydrogen. It can go on the top or the bottom, it doesn't matter for these structural formulas. Carbon number 3 has 1, 2, we'll put 3 and 4, and then same thing for carbon 4. Carbon 5 only has 1 bond so far, so we can put 3 more. Let's fill these in with hydrogens. I already did 1 here, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Hopefully your drawings are much nicer than mine. Alright, so that's pentene. Let's take a look at heptene now. Hept means 7, so we'll plug this right into the formula. C7, and it's H, which is 2 times 7, so we should have C7H14. And I'm just taking this from the general formula, which I can take straight from table Q. So let's draw this. So we have a double bond between the first 2 carbons, and again I'll show you later on where the double bonds could be elsewhere. So we have carbon 1, 2, carbon 3, 4, 5, 6, and 7. All right. So we'll go ahead and put in those hydrogens. We have 1, 2 bonds already for carbon 1, so we'll put 2 more there. Carbon 2 has 1, 2, 3 bonds, so we'll put another hydrogen. Again, it can be on the top or the bottom, it doesn't matter. Carbon 3, we can put 2 more bonds. Same thing, 4, 5, and 6. And then carbon 7 only has 1 bond so far, so we can do 1, 2, 3, 4. Now we filled all of these in with hydrogens. So I already started over here. I have 1 hydrogen, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Alright. So we'll go ahead to the alkynes. Now, what do you notice about these alkynes? Okay, they still only have carbon and hydrogens, but now we actually have a triple bond between 2 of the carbons. And all of these names end in yne, Y-N-E. Their general formula, which you can take straight from table Q, is CnH2n minus 2. And this is also another unsaturated hydrocarbon. Make sure you write down that they have that these are unsaturated hydrocarbons, meaning that instead of having this carbon attached to 2 more hydrogens, it actually has a triple bond with another carbon. We'll do the same exact thing. We'll take a look at table Q. The alkynes are listed right down at the bottom. This is their general formula, and we see that they have a triple bond. So we can see just from table Q that ynes have triples, enes have doubles, and anes have singles. It's not like we have to memorize them, but they will probably come into play, or you probably will learn to memorize them. So we have the general formula, CnH2n minus 2. We will go ahead and double check all of these just to make sure we know how to plug them in. Okay. So we have ethene, or ethine, excuse me. Whoa, that's ethine. Ethene would be E-N-E. So ethine has 2 carbons, so it's C2. And then we plug in H, just 2N minus 2. So we still have C2. And then let's look over here for the hydrogens. 2 times 2 is 4, minus 2 is 2. So we'll have H2. Let's double check. 2 carbons, 2 hydrogens. All right, let's take a look at propyne. So we know that prop is the prefix 3. We take that from table P. So we have C3, and then H is 2 times 3 minus 2. So it's C3. So 2 times 3 is 6, minus 2 is 4. So we have 1, 2, 3 carbons, and then 1, 2, 3, 4 hydrogens. So that's good to go. And then butyne. So but has a prefix 4, so it's C4. And then let's fill in for hydrogen. So it's 2 times 4 minus 2. So we have C4. Alright, so 2 times 4 is 8, minus 2 will give us 6. Let's double check. 1, 2, 3, 4 carbons. And then 1, 2, 3, 4, 5, 6 hydrogens. We have our examples here with pentyne and heptyne. Go ahead and pause me. Do both of these examples. Alright, so for pentyne, we should have, let's see, whoops, C5, and then H is 2 times 5 minus 2, so C5, H, and then this is 10 minus 2 is 8. We know we have a triple bond between the first 2 carbons, so let's put those bonds in there. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then we'll label them 1, 2, 3, 4, and 5. Get used to numbering them because they do come in handy. I'm numbering number 1 over here because that's where my triple bond is. So let's put in those hydrogens. Carbon 1 already has 3 bonds, so that can have another bond. Carbon 2, we have 1, 2, 3, 4 bonds, so there will be no hydrogens around carbon 2. Carbon 3 only has 2 bonds, we'll put 2 more there. Same thing with carbon 4. And carbon 5 only has 1 bond, so we'll put 3 hydrogens around. Let's go ahead and put them in. 1, 2, 3, 4, 5, 6, 7, and 8. So, how'd you guys do? the next is heptyne. So we'll have C7, and then H is 2 times 7 minus 2. So we have C7, 2 times 7 is 14, minus 2 will be 12. So we'll do 1, 2, 3 between the first and second carbon. So we have 1 carbon, 2, 3, 4, 5, 6, and 7. And we'll go ahead and number them 1, 2, 3, 4, 5, 6, and 7 just to make sure we're good to go. And then we will go ahead and put in the hydrogens. So we have carbon 1 already has 3 bonds, so only put 1 there. Carbon 2 has 1, 2, 3, 4 bonds, so that will not be allowed to have any more bonds. Carbon 3 only has 2 bonds, so we can put 2 more. Same with carbon 4, 5, 6. Carbon 7 only has 1 bond right here. I accidentally drew another one right there, so it's 1, 2, 3, 4. And let's fill in the hydrogens. We need 12 hydrogens total, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Alright, so this pretty much just shows you how to draw in all of these bonds. So as a summary for this, and I don't know if I have a summary screen, I don't. So your summary is use table Q and make sure that you remember how to add or at least put in all of the hydrogens and how to use the general formulas from table Q to identify if it's an alkane, alkene, or alkyne. Most of the time this will be a multiple choice question, so just plug in the number of carbons into each of the general formulas and see if the hydrogens match up. Also, don't forget to use table P for all your prefixes. Hopefully you guys have a great day. Take care.